Don't forget to like, subscribe, and comment and share. Now today, I want to talk about the compositions of functions. Composition of functions. We have talked about the introductions of mapping and functions. We have talked about the inverse of functions. We have talked about how to determine the value of the functions. But today, we want to talk about the composition of functions. Now, let's take a look at these examples. They say if f of x is equals to s squared, f of x is s squared, and g of x is 2x minus 1. Find, remember figure 1 said we should find, remember figure 1, g of f of x. G of f of x. Now, if you follow this thing you see, g of f of x, there are two things that are together. That's what we call the composition of functions. The first one, this is how we do it. G, write G. And what is your f of x? Our f of x is s squared. That means g s squared. That means you have resolved it to f of x is s squared. Now, if you now want to follow the second pattern, what is g of s squared? G of s squared is talking about this. That means g of s squared equals to anywhere I see x in g of x, I'll put s squared there. 2 open bracket s squared minus 1. That means our answer is 2s squared minus 1. So that is for the fourth example. Now for the Roman figure 2. For the Roman figure 2. Roman figure 2 says we will find f of g of x. F of g of x. That means what is g of x in front of f? Our g of x is 2x minus 1. Means 2x minus 1. So that means in f of x, like you see this arrangement now. So that means in f of x, anywhere I see x, I'll put 2x minus 1. And we have s squared. That means for x here, I'm going to put 2x minus 1 all squared. Don't forget. So if I expand it, that means 2x minus 1 to bracket 2x minus 1. That is 4x squared minus 2x minus 2x plus 1. That means 4x squared minus 4x plus 1. So that is for the Roman figure 2. When we look at this on the board, that's our example 2, number 2. Is that if f of x is 2x plus 1 and g of x is 2 open bracket x minus 2 close bracket, what is the value of f of g of 1 over 2? Now, what they ask us to do, they ask us to find this f of g. F of g, later I will substitute this 1 over 2. F of g, according to what we see, that means f, what is not g? You follow this, what is g? G is this. Our g is this, that means f of g, and g is 2. G is 2 open bracket x minus 2. And what's that? That means 2 times 2x, 2 times 2, 4. For that. Now, when you now follow this, that means f of g now. Now, substituted g. That means this one now, f, wherever I see for the f of x, this one is standing in form of f of x now. That means in form of f of x, wherever I see x in f of x, I'm going to substitute 2x minus 4. And what is f of x? F of x is 2x plus 1. 2x plus 1. That means I'm going to substitute this for this x. 2 open bracket 2x minus 4 plus 1. This one. This x I substituted this. That means our answer is 2 times 2x. 4x minus 2 times 4. 8 plus 1. That means our answer is 4x minus 8 plus 1 is minus 7. Now let's take a look. Now we have done it, but they ask us to substitute 1 over 2 in our answer. So that means our answer is going to be 4 open bracket 1 over 2 minus 7. 2 here 1, 2 here 2. That is 1. 2 minus 7, that is minus 5. If you look at this, it said if f of x is x minus 1 all over x minus 1 and g of x is x minus 3 over 2x minus 1. Find the expression for g of f. For g of f. The first thing you do, like I said, is to write the g. And what is f? Our f is this. Is x minus 1 all over x minus 1. Do not forget that. Now this one is standing in form of g of x now. In form of g of x. That means wherever I see x in g of x, I'm going to substitute all of this value. And what is g of x? Well, g of x is x minus 3 all over 2x minus 1. So wherever I see x here, I'm going to substitute this whole value. I see x here, I'm going to bring everything. That means x minus 1 all over x minus 1 minus 3 all over 1 divided by 2. I see x here, open bracket, x minus 1 all over x minus 1 minus 1 over 1. Let me say it again. We are given g of f, and g, what is now f? I substituted f first, and the f is x minus 1 over x minus 1. Now, this g of x and g of x. So, that means wherever I see x in g of x, I'm going to substitute this whole value. And g of x is x minus 3 all over 2x minus 1. So, I see x here. I'm going to bring everything I see here. That is x minus 1 over x minus 1 minus 3. That's why you see I just over 1. This line is divided by 2. I see x here. I brought all these values to this place. Now minus 1 over 1. Now let us find the LCM for this. Our LCM for this is x minus 1. Now x minus 1 and x minus 1. That's 1. 1 times x minus 1. X minus 1. Minus x minus 1 in 1. That's x minus 1. Minus open bracket 3 into bracket x minus 1. You have to introduce brackets because of this minus. Now, divided by, let me use this 2 to open the bracket, that is 2x minus 2 all over x minus 1 minus 1 over 1. So these two will multiply the numerator all over this minus 1 over 1. Now, after that, x minus 1 minus 3x minus as minus plus 1 all over x minus 1 divided by, so I need to find the LCM here. Our LCM here is also x minus 1. X minus 1 is x minus 1. 1 times this, that is 2x minus 2 minus x minus 1 in 1, x minus 1, open bracket, x minus 1. Let's continue. I believe you have seen. Now from here, we have x minus 1. Let me just say, to avoid wasting of time, minus 1 cancels plus 1. So we have x minus 3x left. X minus 3x all over x minus 1 divided by 2x minus 2. We use this minus to open bracket, that's minus x, minus and minus plus 1 all over x minus 1. That means x minus 3x all over x minus 1 divided by, now 2x minus x, that is x, minus 2 plus 1, that is minus 1 all over x minus 1. 2x minus xx, and minus 2 plus 1 x minus 1 all over x minus 1. So that means we are going to have x minus 3x all over x minus 1. Division will change to multiplication, multiply by, and the denominator will come to numerator, numerator will come to denominator. But you see the same thing actually, x minus 1. So this one cancel this. So we have left x minus 3x all over x minus 1. In fact, I can move further by saying that s is common. I can factorize for x. X open bracket 1 minus 3. Yes. 1 minus 3 because s is common all over x minus 1. Which I'm going to say x bracket 1 minus 3, that is minus 2. Minus 2 all over x minus 1. That is minus 2x all over x minus 1. So that's our final answer. I believe by doing this again, we should get to comprehend our composition of a function. Now they say the function f and g are defined over the set R of real numbers as follows. Now we are given f of x to be tan x and g of x to be root open bracket square root of open bracket 1 plus x square close bracket. Now what they now ask us to find, g of f. Find g of f. Now write g and what is f. We're going to substitute the value of f. The f is this tan x. It's still the same pattern. So that means in g of x, they are standing like this. Anywhere I see x in g of x, I'm going to substitute tan x. That means g into tan x, and this g of x, 1 plus, and this x, I'm going to substitute tan x in this place. Tan x all square. So that means root of 1 plus tan square x. And according to the trigonometry, 1 plus tan square x equals to sec square x. Please watch out for our trigonometry. We're going to be explaining all these things. It means this one is sec square x. Sec square x. And which can also be written as sec square x. Now the square root can also be written as 1 over 2. And these two can cancel here. And our answer is sec x. That is all about that. Please don't forget that to subscribe and to like and to share. Please, that's how we can help this channel to grow. Thank you so much as you do so.